This is the presentation of the Af3 system, which include the C4I description. My name is Azoulay Roger, and I will give you a presentation of the C4I. Actually, the C4I system objective are to help the commander to communicate with the command and operate the forces around the area, and control the activity, location, mission status, configuration, reports, and everything will be using via the C4I. Everything will be done via the wireless communication. The concept of the operation will be the display of situation awareness of the background on background map, having a capability to plan a mission, show the commander the fire propagation simulation, make use of decision support, and send the commands to the actuator. In order to do that, we choose the internet to do the communication between all the parts of the system, because it's free and it's very easy to use. So we actually put all the subsystem. We divide all the partner development to a subsystem, and each one has to be connected to the internet in order to move the information and to transfer information from one to each other. So in the way that one of the subsystem need information from other subsystem, he can ask for this data, and he will receive it back on time. We have here the C4I that manage all the database, all the data, all the presentation, and every subsystem is connected, logged in to the C4I in order to be connected and to be known about to other subsystem which one is logged in the system. So if we can see here that we have the decision support subsystem, SRC, which give us the satellite map data, risk data, situation awareness that collect the data from all the end user and present it for the C4I, sensors and device, which is the subsystem that have a communication with the field sensors, get the data, fusion, and send it to the C4I or other subsystem that need this information. Risk analysis that analyze the area and the situation and gives the C4I and the commander the decision and the maps of the risk of the area. End user is the one that collect all the commands and that came from the C4I to the end user in order to do an operation. FFL is the tool that give the commander a way to see what prediction for the fire, where will be the fire within some time. Weather is a subsystem that give us the weather situation on the selection area. It means temperature, winds, and heading of the wind, and so on. CMNG is the population simulation behavior in crisis incident. So all those information will be collected by the C4I and presented to the commander in order to make a better decision while there is an incident, fire incident in the area. In order to do the communication, we decide to use the RESTful protocol that give us a way to make it easy, the communication between the subsystem. Each subsystem is architecture is like a client-server architecture, and a stateless communication, meaning that nobody need to hold the situation at the time. Every time there's anybody that asks for information, the information is on the time that he was requested. It doesn't save any memory for the last question or something like that. So always when you ask a subsystem for information, you get the fresh one that you at the time that you ask. This protocol, RESTful protocol, is being used by the Facebook and Twitter, and we know how it's worked very good there. So we thought that it would be good for us also. And in the uniform interface for that RESTful provide, we have 4 different commands: put, which create a new resource; get information from other; post, transfer a new state into a resource; and delete the resource. For us, we need to use only the post transfer, and it's enough for us to send data and receive data using the post command. So what actually we do in C4I operation? First, we can control all the subsystems and operators around the incident. We can send a emergency rescue guys to help and to give some help in place whenever it's happened on the map. Everything is actually shown on the map, and there is a full control to know where each one of the participants can be shown on the map and where they are going to go. So we can command the UAV to go and observe an area that it's interesting. We can send the police to block roads, and we can see it, of course, on the map and know that the police is resident there and block the roads. Firefighting is being sent by the commander to a place where to start work and to start distinguish the fire. Using the aerial firefighting, helicopter, light air tanker, or advanced area firefighting that use pellets, everything can be done via the C4I by commanding and send the command to the area or ground forces to do the operation. In the same time, we get information from all those participants, all those ground forces and air forces location and what they done, and we can we can get the UAV track on the map, and the video is being displayed in the control room, so we can see exactly where is the fire, the front end of the fire, and what's happening in this time. We have some camera, helmet camera, or a vehicle camera that can be transfer the video to the control room, and in this way the commander can see from the eye of the firefighter or from the vehicle the fire itself. We can know the calculate and see the way that pellets influence the fire by calculating and simulating the drop, and then the fire propagate simulation will give us if this will help to distinguish the fire or not. We get the picture of situation awareness of each of the firefighting in the area. We get the sensor data, and we can know exactly what is the temperature in the point of the incident, and what is the wind speed and direction, and etc. They actually include 3 modes of operation: the real mode, training mode, and training mix mode. The real mode, actually, when you activate the Af3 system to control all the incident fire and control the ground forces and aerial forces. The training mode, everything is being done in the room using the Af3 system, the same Af3 system, and that will help to make the commander and the operator better use of the system, while the training is using the mobile simulation, and they get the command from the commander, and they actually use this mobile simulation in order to do the command that was received from the command. Mixed training, meaning that you can use either the simulation in the room and also send some forces to the area, but actually you don't light a fire. Just send them and see the way that the people is action, and also it's better training for the commander and the control room team. We go now on the C4I operation and capabilities. The C4I actually has a display with a map background, and some icons and ribbons around the map, around the display, that help the commander or the operator to use them while there is an incident. The ribbon is a bunch of buttons that handle all the mission handling, drop vector that we want to do, sometimes to simulate how the pellet is affecting the fire, using also multi-drop, general message that we want to send to the ground forces, using of the newbie in order to preventing fire, getting an image from the end user and display it, and have a drop a fire front area in order to know where exactly the fire is being done in this moment, and running the fire propagation simulation. We have some forms in the C4I, and those are the function that we can use: pellets mission planning, situation awareness, end user data to message send, mailbox, inbox, and outbox. All the data that is transferred is being grouped into inbox and outbox. The icon noob, the way it's displayed on the map, sensor and device, weather, satellite view, and FFL. We use the common symbol, European symbol, in order to show power, to show forces on the map, and some symbols for the UAV, fire station, and things like that. Everything is displayed here, and those are the symbols that will be presented on the map to the command. The ribbon, we have the 4 section of the ribbon that we can actually use it for affecting the system. We have the drop vector and multi-drop. In order to drop pellets, we use this ribbon and draw a rectangle on the map, and then we will see the calculation what will be the effect of the pellets dropping, and it will be displayed on the map. And we can select the area that we want to distribute the noob. Sometimes we need the image data from the UAV, so we can select the image from the UAV and put it on the map. Draw a fire front end on the map, of course. Getting DS data decision support from the system and draw it on the map. Activating the CGF route on the map, show the UAV scan area, deploy by using the icons to deploy firefighting or police or volunteers, whatever, and some local entity that help us to design the mission. This is an example of what we'll see on the weather. We have weather, winds, direction, smoke forecast, and weather control, how we control the weather in order to get the information. This is an example for the smoke. Just on the right hand, we see the control that we ask the subsystem to give us the smoke on some specific area, and then we just it will be dropped and draw on the map. Pellets drop also on the left side. You can see the blue ellipse picture that help us to see where will be the calculated dropping of the pellets, and if we are satisfied with that, we can send it to the area command to do the mission. On the right hand, we can actually change some property of the dropping, like the altitude of dropping, the speed of the vehicle, of the aircraft, and so on. One of the tools that we use the subsystem of the FFL is by giving us a way to propagate the fire, to simulate the fire, where the fire will be in time. So we have on the right hand the control of the fire. We can put sometimes, we can say every 20 minutes within 2 hours where the fire will be, and then we got a drawing fire and we can decide where to drop pellets, where to send firefighting, and etc. It is a very good tool for the commander that help him to understand what's going to be within 2 hours. Probably sometimes he will ask to evacuate people from a village near the fire. From the satellite, we can get the fuel type of the area, and that's by selecting the area, we ask the fuel type and we get the fuel type. And this is also help the commander to understand how what kind of fuel that we have in this area in order to use a mission that is specific for this kind of fuel. The commander can plan a mission and then send it to the post commander, and on the right hand he will see the mission, the mission that are being sent, and the status of the send, if the command has been transferred or waiting for transferring or failed. So in this way he knows that the data is being transferred, or it should be transferred again or something like that. Something else that we can use is the message log. Everything that is in and out from the system is being collected to a log, and in this way you can first using as a debrief at the end and see what happened during this incident, or you can see and roll up and see that things has been sent to messages has been sent or not, received or not, and everything is written on the log, the time that happened and everything, all the information that can be written there, form 2, will be located on the message log and then be saved later for analyzing for the next fire incident. The capsules is being used when the commander asks for to put the capsules for preventing and prepare them and distribute them in the area. So it is a command that can be sent to the ground forces to distribute the capsules, and the capsules is distributed. When the fire is reached, the capsules automatically start to work and try to distinguish the fire. UAV, when we are asking for UAV to scan an area, we have to select the area and then send the request to the Air Force. The UAV will then send a UAV. The Air Force will then send a UAV, and then we will get the video from the UAV to the control room, and we will see the track of the UAV on the map. At the end, we can get a picture image of the UAV and locate it on the map in order to sometimes we want to use it as for mark the front end of the fire. Risk alert, there is a capability for each of the ground forces or civil that have the application, mobile application, to send a risk. When risk is arrived, the risk is in red will be jumped to the commander on the screen, and then he can go into the risk data and see the message along with the risk and do and act accordingly. We use the Skylark for the UAV, and the Skylark is a Elbit production, and we use it in the last Israeli drill. As you can see, the Skylark has a wings span of 3 meters, total weight of 7.5 kilograms. The flight speed is 27 knots. Flight altitude can be from 4,000 feet to 15,000. ASL or AGL for minus from 4,100 to 4,000 feet. With limitation takeoff 25 knots, and with the limitation in flight 35 knots. Actually this UAV is being sent by hand on the ground. You don't need any airport or something to use it. Just wherever you are, you send it on the ground and it start to be flying. The UAV, the Skylark has three cameras: the day payload, IR payload, and dual payload. And they use for the day, it's a very normal camera that gives you the full picture. IR is IR camera in time that you want to, you have a lot of smoke and you want to see the fire, you use the IR camera. And dual have both. And also when the UAV stop to finish his mission, and it can be land on the same place where you send it on ground, and that's it. Thank you very much.